I knew right away that this has a common factor because this has a common factor. What factor do those two terms have in common? They have 3 in common. So I've got to factor out that 3 to be factored completely. Then I know here this will factor again. This is a difference of 2 perfect squares. So I'm going to do several things all at the same time. I'm going to factor out my 3. I'm going to put it out front. And in place of this, I'm going to put 6x squared divided by 3 is 2x squared. And 15 divided by 3 is 5. So although I did not see in the beginning, and I'm sure some of you were saying, there's a common factor, I should have checked closely, but I did not. I just demonstrated to you that although I did not see that common factor to start with, which would have saved me some large numbers if I would have, that you can see that common factor in the end. Okay, now I'm going to replace x squared minus 9 with 2 empty binomials, one with an addition sign and one with a subtraction sign. I'm going to take the square root of x squared. X goes in that first spot of each of those. I'm going to take the square root of 9. The square root of 9 is 3, and 3 goes in the first spot of each of those. So there, finally, is my factored form of 6x to the 4th minus 39x squared minus 135. Now, when I do the bottoms up method, I have to take out this 3 because unfortunately the bottoms up method is not friendly when it comes to factoring by using that method or that algorithm. So I'm going to go ahead over here and I'm going to take out 3. That would have left me 2x to the 4th minus 13x squared minus 45. Is that right? I think it is, but let me check. 3 times 5 is 15. 3 times 4 is 12 plus 1 is 13. Yes, that's right. Okay, so then I need to make a new chart. And I'm going to bring this 3 down here to my answer. Let's see. A is 2, B is negative 13, and C is negative 45. So I need factors of negative 90. That'll give me a sum of negative 13. Factors of negative 90, 10 and 9, but that's not going to give me negative 13. 2 and 45, obviously, that's not going to give me negative 13. 9 times 5, but I need a negative 9 and a positive 5, so that's not going to work. 6. Let me write some of these down. 1 and negative 90, 2 and negative 45, none of these work yet. 3 and 30, negative 30, that doesn't work. 4, I believe 4 does go into it, but I could be wrong. 4 goes into 9 2 times. No, I don't think so. Nope, that's wrong. I don't know what I was thinking. 5 does. It goes 18 times. There we go. That's what I thought it was. So 5 times negative 18, that's what works for me. Okay, so I'm going to put x squared in this place and this place. Don't forget you're going to use the middle variable. I'm going to put plus 5 and minus 18. Then a is not 1, so I'm going to put a underneath both of these. I'm going to reduce if possible. Five halves will not reduce. 18 over 1 reduces, 18 over 2 reduces to 9 over 1. I'm going to do bottoms up. So 3 times 2x squared plus 5. And then 1x squared minus 9. And then I need to recognize that I have a difference of squares here. So I still get the same answer two empty binomials, one with an addition sign, one with a subtraction sign, and take the square root of x squared and the square root of 9. So I did get the same answer. Notice, though, that this answer is in a different order from this answer. So it's the same answer, they're just in a different order. Remember, multiplication is commutative. Okay, on to the next example. I'm going to try to do better with those common factors. I apologize for that. Okay, so let's look at number 3. And I'm going to have you try factoring by grouping just to check to see if you can get the correct answer. So here we go. I don't have a common factor. I've checked closely. 13 is prime, so I won't run into that circumstance. I'm going to name A, B, and C. I'm going to make my chart. A times C, sum of B. I believe that's 4 times 9. That's what works. I'm going to put two empty binomials. I'm going to use the middle variable x. I'm going to put positive 4 and positive 9. And I'm not going to stop there because A is not 1. A is 6. I'm going to reduce. These are both divisible by 2. So I'm going to reduce that to 2/3. These are both divisible by 3. I'm going to reduce that to 3/2. So I reduced, and now I'm going to do bottoms up. Bottoms up. Remember, the denominator becomes the coefficient. So this would turn into 3x plus 2 and 2x plus 3. Let's check quickly. 6x squared, check. 9x plus 4x is 13x, check. Plus 6, check. So that's correct. Okay, let's try number 4 again. You try factoring by grouping. Let's try number 4. I'll have you try factoring by grouping for that one as well. I do have a common factor of 3. Every one of these are divisible by 3. So I'll take out that common factor, 4x squared plus 3x minus 1. A is 4, B is 3, C is -1. I want to bring my 3 down here to make sure I include it in my answer. Make my chart, A times C, sum of B. So factors of -4, that will give me a sum of +3. That would be +4 times -1. Make sure when you write that down that you know that 4 plus -1 is +3. A lot of students would put -4 and +1. That would give you a -3. It does make a difference. Okay, so then I'm going to bring down my middle variable x. I'm going to put +4 and -1. And now I'm going to remember that I'm factoring a trinomial where A is not 1. So I'm going to put the A value under both of my new factors that I put in my parentheses. I'm going to reduce. And you don't have to put this 1 here. I'm just putting it here so that you can see 1/4 does not reduce. And then bottoms up. That denominator becomes the coefficient, not out here in front where 3 is. So 1x plus 4 times 4x minus 1. Then let's see. X times 4x is 4x squared times 3 is 12x squared. -1x plus 16x is 15x. That's not correct. Oh, duh. 4 divided by 4 is 1. See, that's why you check, because I made a mistake. 1/1. Whoopsie. I'm sure some of you noticed that already in this video, and that's okay. It's actually good, so I can see who actually was paying attention and didn't just copy all this down. Okay, so I've got 4x squared times 3 is 12x squared. I've got negative 1x plus 4x, which is positive 3x times 3 is 9x. I have 1 times negative 1, which is negative 1 times 3 is negative 3. So that is the correct answer. One more to go. And it's a little different. Okay, so here it is. 2x to the fourth minus 8x squared minus 42. Hopefully you notice these are all even, so 2 is my common factor. 2x to the fourth divided by 2 is x to the fourth. Negative 8x squared divided by 2 is negative 4x squared. Negative 42 divided by 2 is negative 21. Okay, now, do you notice that a is 1? So since a is 1, I do not have to do bottoms up because my a value is 1. Okay, so I'm going to bring down that 2, put my 2 empty parentheses, and then make my chart. A times C, sum of B. What can I multiply and get? 21, 7 and 3. Yes. 7 times 3. When I want to put these together and make negative 4, so that means one of them has to be negative. Since 4 is negative, the bigger one will have to be negative. So that would be x squared. Remember, use your middle variable. Minus 7 and x squared plus 3. Now, I do have squared terms, so I want to look for a difference of squares. This is a sum, so that's finished. This is a subtraction sign, so then I need to look to see if both of these are perfect squares. Yes and no. So this is my final answer to this one. You may also try factoring by grouping for this one because it will work. You can take this and group, use x to the fourth minus 7x squared plus 3x squared minus 21. One final thing I want to say, if both of these would happen to be negative and you're factoring by grouping, don't forget when you do the grouping, let me find my page over here. When you do like we were doing here, don't forget to put a plus sign in the middle. And when this first term is negative, regardless if both of these are negative, when this first term is negative, you're going to factor out a negative sign. That's just kind of an unwritten rule that you're going to take out a negative so that the signs of both of those would match. Okay, I hope that helps factoring by grouping.